Section 1.4, we're going to be talking about properties of real numbers, and when I say that, I mean that relationships are always going to hold true for those real numbers, and we use that to be, a property, which we can use to rewrite and compare some expressions. And we know that two algebraic expressions, remember expressions that contain variables, are equivalent if they have the same value for all values of the variables. The following properties show expressions are equivalent for all real numbers. And first one we're dealing with here, and again, we're just talking about A, B, and C as just some numbers that we can switch around, mean to be anything. First one is the commutative property, and we have that for both addition and multiplication that it works for. And that means that changing the order of the addends, so the two things that you're adding, in this case for addition, doesn't change the sum, and change the order of factors, again for multiplication, doesn't change the product. So the reason why I circled that CO at the beginning of commutative, I think it's a good way for me to remember at least that means that you're changing the order. So commutative property, CO, you're changing the order of those addends and factors. If I write A plus B, same thing as B plus A, I can reverse that. A times B, same thing as B times A. So that's the commutative property. The associative property, again, it works for both addition and multiplication, means that changing the grouping of addends doesn't change the sum. So again, doesn't change the sum if I group them differently. Also, same thing if I group different factors together, it doesn't change the product when we multiply. So you can kind of think associative. When you associate with different people, maybe A and B are hanging out here together, they're all under the parentheses and then plus C. So that result, if I add A and B first and then add C, it's going to be the same as if I group these together instead. So A plus B and C put together, that should be the same result. Same thing if you multiply. If you multiply A times B first and then multiply C, that's going to be the same answer as if you multiply B and C first and multiply A as well. So again, if it's addition or multiplication, we can change the order, commutative, or we can change the grouping, that's associative. So for any real numbers, and again, this is just saying let A be any kind of real number. It can work with a bunch of different numbers. The identity property works for, again, both addition and multiplication. Sum of any real number in 0 is that same number. So again, for addition, if I take a number and add 0, I just get nothing added to it. So yeah, that's just that number again. The product of any real number in 1 is the original. So same kind of idea, but with multiplication, if you multiply times 0, you're not going to get the same thing back. That way you have to multiply times 1. So like 6 times 1, I guess in this example 67 times 1 still gives you 67. So it doesn't change. Zero property works for multiplication. If I multiply any number times 0, I get 0. So again, doesn't matter what the number is. Anything times 0 is 0. Multiplication property of -1, kind of along those lines. If I multiply -1 times any number, I get a negative of that result. And actually, I don't want to say negative. We actually get an opposite. So if I take negative times a positive, so -1 times 9 in this example, I get a -9. But say, for example, if A was -9 instead, then negative times a negative, that would change that to a positive 9. So you want to think that multiplying times -1 keeps that same number, but it just changes the sign. So we got a couple practice problems. See if you guys can try those first. Give you a second to get that done. And again, probably want to pause the video before, but the property that's illustrated by that first statement, and what I do on a lot of these, and I'm fine with this on homework or test too, as long as I can tell what you're going for, is I shorten that up. So 4x times 1 equals 4x. That's the identity property of multiplication. Again, that means that any number I multiply times 1, I get that same number back, or expression in this case. And the second one, I actually made that mistake because that parentheses is kind of there to throw you off. Notice the parentheses don't change here. I was all ready to associate those differently. The only thing we changed was the order. So first we had x, then the square root of y, then z. Instead, this next one is x, and then z, and then the square root of y. And those all being added together. So the parentheses didn't change. What did change was the order. So again, CO changed the order. That's the commutative property of, that should be cut off a little bit there. In this case, commutative property of addition, because I'm adding those together. So what we can also use commutative property for is to help solve some problems using mental math when otherwise they might have been a little bit harder. So on the back, I think there's a practice question. You might want to pause to get that one done first. I'm going to look at it now. So let's go up and cover some of that bottom stuff up as well. So in our practice question, a movie ticket costs $7.75. A drink costs $2.40. Popcorn's $1.25. What's the total cost if you buy all three? And mental math makes this easier if we change the order. So 775, 240, those don't really line up too well together. But if you imagine I switch the order, I add the movie ticket cost to the popcorn cost, 7.75 plus 1.25. That's a little bit easier to add together in your head. Again, I just kind of listed it there. But you could do this mentally, add those, that's like 3 quarters and 1 more quarter. I get $9 total. And then I can just throw that drink cost in there. That's easy enough to add in. After that's just a nice even 9. If I add in 240, I get $11.40 total. So then moving on, again, go ahead and try these questions first before we get to them. But trying to simplify in this case. Let's get all those practice problems in there, I guess. So this first one's a little bit tougher, but the way I broke this apart, and again, this is kind of like using your commutative property where we're changing the order, or you can also think kind of changing the grouping, is if I'm trying to multiply these two decimals together, it's kind of hard to do in your head, but what I did was I took 4.5, I kept this the same, I multiplied that by 2 first, not 2.1, just 2. So 4.5 times 2, that would give you 9. It's easy enough to double in your head. And then if I'm taking 4.5, I still have that 0.1 in there. So easy way you can think of this is just 45 times 1 is 45, but I have a 0.5 and a 0.1, so I need to make 2 decimal places, 0.45. If I take those two things together, 9 plus 0.45, I get 9.45x. On the next one, all I'm doing is changing the order so that I can take the 6 and the 3 together. So I have 4h plus 6 plus 3, that makes 4h plus 9. On last one, I just kind of broke this apart and see what we can simplify. So 8 over 12, I can reduce that. 4 goes into 8 twice, 4 goes into 12 3 times, so that's 2 over 3. M and M are going to cancel, and I have a 1 over n at the end. So if I multiply everything across the top, 2 times 1 times 1, I get 2. 3 times, 1 times n, I get 3n. So looking at our next rule, in the problems above, reasoning and properties, we show that two expressions are equivalent. Again, equivalent means that they're going to be equal. This is an example of something we call deductive reasoning. Deductive reasoning is where we can reason logically from some given facts and reach our conclusion. Again, just using logic and using those facts. So to show a statement's false, all we have to do is find an example for where it's not true. An example showing that a statement is false is a counterexample, so that's your example that shows it is false. You only need one counterexample to prove something's false. So in our example here, again, you want to try these, see if you can get these before we get them. Go ahead and pause, and looking at those now. We have to reason whether a statement's false. If it is, we can give a counterexample. If it's true, we have to use properties to show that they're true. So let's look at those couple now. And I'll just put that lesson summary down there too, and you can kind of check your work. First one, we have to say if we have j and k, j times k, is that equal to k plus 0 times j? And what I did was I looked at that k plus 0 part, and we know from the identity property of addition that k plus 0 is the same thing as k, because adding nothing doesn't change it. And also, if I just replace that, so k plus 0 is now just k, so on the right-hand side, it's just k times j. And we also know from the commutative property of multiplication that changing the order of multiplication doesn't matter. So j times k, k times j, same thing. That statement's true. We just proved it with those two properties. For our next example, all real numbers m and n, m times the quantity n plus 1, so that's in parentheses, equals m times n plus 1. So we're going to have to see if that's true or not. And I didn't think that was, so I came up with a counterexample. So let's say m is going to be 2, and let's say n is going to be 3. Let's see if that works. If you plug those in, so plug in 2 for all the m's that you see, and 3 for all the n's that you see, and it doesn't have to be 2 and 3, that's just the counterexample that I came up with. If I follow my order of operations, I see that one side reduces to 8, the other side simplifies to 7, so that's going to be false. Those two sides are not equivalent. So go ahead and make sure you've done that lesson summary as well, and have these notes for when we're back in class.